Welcome. This is a quick recording for a step-by-step process on how to calculate the average atomic mass. So the slide you're looking at now is how to calculate percent or change a percent to a decimal that you'll need in order to do the calculation. So this is just review, but if you have 23.569%, and you want to change that to a decimal because you can't use percents in your calculations, they need to be in decimal form, then you change or move the decimal 2 places to the left. So I'm going to go 1, 2, and so 23.569% is equal to 0.23569. You're just moving the decimal twice to the left, or really what you're doing is dividing by 100, right? Percentages are by 100. So if you want to grab your calculator, you could divide by 100, but when you divide by multiples of 10, you move the decimal place to the left as many zeros as you have. So 100 has 2 zeros, that's 2 places to the left. So again, percent to a decimal, move the decimal point 2 places to the left. For the second one down, we have a 0 in front, so we have to add in zeros after we move. Let me get a drawing tool. Okay, and so I'm going to move this decimal 1, 2. And because I've moved it 2 places, now I'm going to have to fill in a 0 here to make it work. So 0.578% becomes 0.00578. So you have to add in another 0. So 2 places to the left, fill in the zeros if you have to. Same thing with the bottom one, it's even smaller. Right? So I'm going to take that decimal place. Let me grab another drawing tool. And I'm going to move the decimal 1, 2 places to the left, and I'm going to fill in my 0. I'll fill it in this time. So I'm going to fill in my 0. And so now, and it looks like a diamond for whatever reason, that's supposed to be a 0. And so now I have 0.000274. Right? So 0.0274% becomes 0.000274. All right, so percents to a decimal, move the decimal 2 places to the left. All right, so let's look at our first problem example that we did in class together. So I want to calculate the average atomic mass of chlorine. I already know what it is. If you go to the periodic table, it's 35.453, right? So the average atomic masses are already done for us. The goal of this is to understand where that number is coming from and understand that weighted average calculation behind it and how it relates to isotopes. So anyway, to do an average atomic mass calculation, there's 6 steps to follow over here. So the first step says to list out the isotopes. And so I'm going to go ahead and read through the problem and then list out the isotopes that are given to me. And so it's not 100% necessary if you're on your own to list out the isotopes, but it keeps you organized. And so if I go back up into the problem, it says naturally occurring chlorine is 75.77% chlorine 35 with atomic mass 34.969 AMU and 24.23% chlorine 37 with atomic mass 36966. So if I go back in the problem, I want to list the isotopes. The isotope name, I have chlorine 35 and I have chlorine 37. So all I'm doing is listing those out in my first step. So I'm keeping myself organized. The next step is to go find the percents and change them to a decimal like we were practicing. And so the first one says 75.77% is chlorine 35. And so I'm going to move that decimal point 2 places to the left and get 0.7577. And I placed it right across from chlorine 35 because that's where it goes to. Now I'm going to do the same thing with 24.23%. So again, I'm going to move that decimal twice to the left and get 0.2423 and put it across from chlorine 37, again, to keep yourself organized. Step 3 says to list the masses in atomic mass units that you're given in the problem. And so if I go back into the problem, they give me chlorine 35 is 34.969, so I've written that in. And chlorine 37 is 36.966, and I've written that in. And so before we go any further, again to review, step 1 is to list the isotopes by name just to keep yourself organized. So chlorine 35, chlorine 37. You don't use those in the calculation, that's just the name to keep yourself organized. Then next to it is step 2, change the percents to a decimal and list them out. And so 75% became 0.75 and 24% became 0.24. We moved the decimal point twice to the left. Then I'm going to do step 3, which is to list the masses in atomic mass units that you're given in the problem. And so the mass, the first one I'm given is 34.969, again, atomic mass units. And the second one is 36.966, and all I do is list them in. So the only thing that you're really changing is the percent to a decimal. Everything else you're just pulling from the problem that you're given and writing it, so keep yourself organized in kind of a chart form. And so now we're in step 4. Step 4 says to multiply the percent, decimals, and the masses. And so if I go across, I have 0.7577 times 34.969. So you're just going to multiply across. Remember, this first column is just a name, so you don't have to use that in the problem or in the calculation. You're just going to multiply the percent that's changed to a decimal times the mass. And if you grab a calculator and do that, you should get 26.496. And then you're going to do the same thing for the next row. So 0.2423 times 36.966, and there's my number. Step 5 says to add up the results. So now I take those two numbers and I add them together, and I got 35.45. What I should also have here really is the units. So those are atomic mass units. So I could put that next to it so you could see. So your final answer in chemistry really should have a unit next to it. So those are AMUs. And then finally you have one last step, which is step 6. You could check your work because again, these are already done for you. They're all on the periodic table. So you could go over there and make sure you've done your calculation correctly. So I went over to the table, I found chlorine. And it says chlorine is 35.45, and we got 35.45, so we've done it correctly, we've checked our work, and we're good to go. For our purposes in here, if you're off by a little bit, so if you get 35.6 or 35.2 or something like that, that's fine. Just as long as you're within a, I don't know, 0.3 of something maybe. But as long as you're close, we're okay. All right, let's do one more together. And then I have some practice in the video. You can pause the recording and give them a try if you choose. This is the other one we did in class. This one is lead. Lead has 4 isotopes instead of 2, but you do everything the same. You still follow all the same steps. You just have 4 rows now instead of 2 rows. And so again, it says step 1, list out your isotopes. And this time they've already given us the chart. Right? In the first problem, it was a word problem. We had to write the chart ourselves. Now, really, we're just pulling a lot of this down, right? So we don't need to know protons and neutrons. It's giving us that information. But here's our isotope symbols. And step number 1 is to list them. So I could just take this and list it. The reason why I didn't is because it's really difficult to type those numbers kind of as superscripts when you're going. It's a lot quicker to do what I did. So instead of writing PB, I wrote lead out, and then I put -204 after it. It's just another way to write an isotope symbol. So if you wanted to write it the way it appears in the chart is fine. If you want to do what I did is fine. So step number 1, I've listed all of the isotopes. They're listed here. Step 2 is to change the percent to a decimal. And so this column here is percent. So when you're looking at data table information in chemistry and physics and a lot of science classes, they don't put units next to the numbers in the data table because eventually they take the data and go to graph it, and when you try to do that with symbols in there or units, then it doesn't work. And so we keep the units at the top of the column. And so you want to be careful. These are actually percentages because it says percent abundance up here. So you're not going to see that percent symbol, but they tell you at the top of the chart that that's what it is. So you want to be careful. We still have to change these to a decimal. So that's step 2, change the percents to decimal. That means move the decimal twice to the left. So 1.4 becomes 0.014, 24 becomes 0.24, 22 becomes 0.22, and 52 becomes 0.52. Okay, so we change percent to a decimal. Step 3 is to list the masses. And again, it's already in table form for us, so all I had to do is take this and put it down here, right? So in a word problem, you kind of have to weed through it and find the information. Here they've given it to you in table form, so you could just take it back down. The only thing you want to be careful of, even in the first problem, is changing percent to a decimal, right? And so now step 4 is to multiply across, or multiply the percent, the percents changed to decimals times the masses. And so I take 0.014 times 203, get an answer. 0.241 times 205, get an answer, and I go the whole way down. I go each one across. Step 5 says to add them all up. So I added all of these up, and I got 207.218 atomic mass units, or AMUs. Step 6 says check your work. So I could go to the periodic table, find lead, and it says the average atomic mass of lead is 207.2, and we got 207.2, so we're right on the money and we're good to go. Right? So if you follow those same 6 steps, it should take you through each of the problems. They're all done the same way. And again, you can always check your work. And so really the biggest kind of mistake usually comes from that percent to a decimal piece. You just want to be careful that you're changing those to a decimal correctly, and then everything else usually falls into place. But if your answer ends up being a lot bigger than what you had anticipated or what it says in the periodic table, then my guess is you may have done the percent to a decimal incorrectly, or maybe forgot to do it, and that would make your answer a lot bigger. So I'd go back and check that first. All right, we did 2 practices in class in that Google Doc that I was watching, so I have them on separate slides here with the answers. So this was the first one we tried in class. This one is written in word problem form. The steps to solve are up here in the top right. And so I'm going to, if you want to, if you want to, you can pause the recording here and give this one a try. And when you're ready, put the recording back on. I'm going to flip to the answers on the next slide. So pause here if you'd like to. All right, I'm going to go ahead and flip to the next slide. It's going to give us our answer worked out. So you could go and pause the recording here, check it with what you have, see how you did. Remember, you can also go to the periodic table and check your answer there. So 10.81, 10.81. The second one we did in class was potassium. And this one could be a little tricky because if you look at these percentages here, these 2 numbers are pretty small. And so that's why with the practice percent to the decimal we did in the beginning, that's why I did it in the beginning. So when you get to those really small numbers, you're making sure you're still moving the decimal twice to the left. Right, so if you'd like to, you could pause the recording here, give this one a try. Again, the steps to solve are up in the right-hand corner. So pause here if you'd like to try. Right, I'm going to go ahead and flip to the next slide. It has our answer on it. And here we go. So we've listed out all of the isotopes. Again, I wrote them this way because it's just easier to type. But they're already in table form here, so you're just taking them down. The percentages have to go to a decimal. So this one, 0.00117 and 0.067, you just want to be careful with those. Those are small numbers, and when you change them to the decimal, they get even smaller, right? So you just want to make sure you've done that correctly. Check your work. Then we write down all of the masses that are given to us. It's already in table form, so just put it down, multiply across, add them up. And so I got 39.14. If I go to the periodic table, it says 39.09, which is completely fine. That's close enough. And so you can check your work and you know you've done it correctly. So I would go through this recording again, and if you still have some questions or if you'd like to do some more practice, please let me know. The homework that's associated with this also has a problem on it for you to write out and try. The help sessions are on Thursdays, so again, let me know in class if you'd like a private session or if you'd rather stop by the help session, and let me know if you need anything.